been around for decades, and again, it's been steadily improving. There's been a little bit of a step change with deep learning in the last few years that's sort of reduced the error rates. But nevertheless, it was also on a path of steady improvement over a number of years. That's obviously important. If the device can't actually understand what you're saying or can't hear the words that you're saying, you aren't going to get the experience. Another part of the technology is natural language understanding. So once you have that text, to a computer, that's a sequence of letters. What is the meaning? What is the intent of the customer? What is the customer trying to ask Alexa, ask the assistant? That's also extremely difficult technology. That's also been improving. There's, if it's a question, how do you actually answer that question? How do you reason to produce an answer? How do you action the intent once you understand it? And then finally, there's also the piece about turning the result, what Alexa wants to say, back into text. So how do you turn back into sound? So then how do you actually create that experience of speaking to a device, it understanding you, doing what you want, answering your question, and then producing something straight back? That's exactly what you're looking for. And as I say, all of these technologies are really difficult. They've been around for a while. They've all been steadily improving, and they've kind of crossed this magical threshold point. And I think they'll continue to improve. So the commercial success that Echo and Alexa have had is resulting in massive investment in the space. Massively strategic for Amazon, hiring thousands of people. Other companies, like Google, have got competing products also fighting for that space. So there will be continuous incremental improvements in all of those technologies, which will also result in a better overall experience for the product.
Great. Mark, at Babylon, you're working on the medical space and producing diagnostic AI. How do you think about what type of AI to use, whether it be deep learning or probabilistic algorithms?
So it's a great question, and I'll echo what William just said. It's never one technology unless you're doing something very narrow, right? It's a combination of technologies. So we try to think about a human doctor and their brain, and then what are the parts of that brain that we need to implement in AI. So it starts with the knowledge. How do you capture the knowledge of medicine, which is a fascinating subject because any doctor goes through years and years of training. How do you train your AI machine to do the same? And then, of course, you need to be able to communicate to people, whether through text or through speech. So that's a big part of what we do. But the biggest part is, what you mentioned, is probabilistic. It's all about diagnosing, because diagnostics is not an exact science, right? It's never the case that if you have pneumonia, you're guaranteed to have high fever. There's always a probability there associated between a disease and a symptom, or a risk factor and disease. So you have to think in a very probabilistic way. And deep learning is a part of what we do, but it's not the most important part at the moment. And I think deep learning has been sort of at the forefront of the news cycle, but AI is a much bigger field than just deep learning.
Right. And how important is the audit trail of what the AI is doing to you?
It's extremely important, right? Because we are in a heavily regulated field, so you can't just say the machine diagnosed the patient and the machine thinks they have cancer, and we don't know why, right? But machine said they have cancer. So that's actually where probabilistic methods are much stronger than deep learning in terms of having this trail and then saying, well, if you look at all the risk factors and all the symptoms and all the tests, then that's how the machine came up kind of with this conclusion. So yes, for us, it's hugely important.
Great. Martin, at Peak, you're working with companies who probably don't have much knowledge of AI. So how do you educate them on the capabilities? How do you educate them that this is worth doing and the benefits that they can get out of this technology?
Sure, yeah, it's a good question, actually. And I think one of the challenges of our job is to help people understand what is possible. First of all, what is the problem they're actually trying to fix? And a lot of people don't know what that problem is. They kind of hear all this buzzword in the industry around AI, machine learning, and I want some, but I'm not sure why. So we tend to start with the real simples of what are you trying to achieve as a business? And it can be as broad as we just want to improve our EBITDA from 6 million to 10 million by next year. Then we'll get into some hunches of where that improvement could come from. And then we would start to drill a little bit deeper around, is the data that this business actually collects and sits going to be useful for us to be able to work using our AI capability and our data science team to drive that performance that they're looking to achieve. So I think we got to be kind of careful, really, because we focus a lot on technology as people. The media is all about the acceleration of the tech. But I think we need to sort of simplify it a little bit around what is it we're actually trying to achieve, and then let's find the right tech for that, not let's build the tech and hope it fixes something that we've not thought about.
Great, great. Okay, I want to move on to kind of think about differentiation for an AI business, because we hear a lot about these massive compute platforms from Google or Amazon or IBM. It seems many of the algorithms for how you do AI are pretty much open source. So how does a business differentiate? I guess, using the Alexa platform as an example, some people consider that's the leading platform for doing this human voice recognition and understanding of natural language. Do you think, William, that's a permanent advantage, or are other people kind of catching up quite quickly on the technology side?
So, I mean, specifically for the sort of voice assistant, in the voice assistant space, yeah, I mean, Alexa is regarded as the leader. But I don't think there's a massive difference in terms of AI and machine learning across the really big technology companies. I think they're all investing heavily. They all have very large amounts of capital. There's a big community of machine learning scientists and specialist scientists, and they're all. I take speech recognition, for example. There is a community of people that have been working in turning sound into text for a very long period of time. They all know each other. They all go to the same conferences. They all collaborate and write papers. They all move from company to company, and they all kind of try and recruit each other from within each of these companies. And they all work. Currently, there are large numbers of them working for Amazon. There are large numbers of them working for Google. There are large numbers of them working for Apple. So yes, I don't think you can certainly point at particular products and say Google's better at this or Amazon's better at this. It's not clear that there's a long-term that one company is going to massively dominate it. I mean, sometimes you get advantages from the data. If you have a product out that collects data, that can give you an advantage that's difficult to catch up. But there are ways around that. There are ways of bootstrapping. So I actually don't think the big companies. The really big companies, I don't think there's a huge difference between them, is my take.
Great, thanks. Janet, the StoryStream business, I understand, has been repositioned all around AI.
Yes.
And we just talked about these big companies like IBM or Google, who are also trying to sell to companies to help them maximize their marketing using Watson, for example. So how, as StoryStream, do you build a competitive advantage in the area where you've got these giant Goliaths kind of possibly trying to do the same thing?
Well, it's all about specialization and really understanding the data and the problem that you're trying to solve. If you're looking broadly and you just want a generic object recognition or generic text understanding, then yes, the big players will give you that. But that won't give you that much more insight. You have to go a lot deeper and really understand your problem and really understand your data. Otherwise, you'll end up with a solution that doesn't do what you need it to do. It'll give you the wrong results because it's only as good as what you put into it. So understanding what's the signal to noise ratio, are you putting that right data in, is it biased, and then being able to calculate the outcome of that. That specialization is where companies like my own can really add value.
Excellent. Mark, similar question to you. We hear about IBM Watson have digitized all of the health records in the world and kind of saying that they can do wonderful things with that. At Babylon, how do you go a step beyond and how do you build a sustainable advantage?
And I'll have to echo Janet this time, right? So it's a specialization. That's what startups do, right? Babylon we are a fairly large company, but we're still a startup compared to IBM. And you're absolutely right that open source algorithms are available, but these are very generic algorithms. How to adapt them to a particular domain, that's a very hard subject. And that's what we have been doing. And also, again, healthcare is a very deep space, right? So there's a lot of knowledge there that's already available. You can't start training systems from scratch, just saying, give us all the data, we'll start training systems. So one of our secrets is we have a lot of doctors working with us, and we are building systems that capture their knowledge. And when you marry these two approaches, learning from data and learning from experts, then you build a system that actually can win. I don't want to comment too much on Watson, but that's our approach.
Okay, great. Okay, I wanted to kind of move on to kind of building the team in an AI-led company. We hear a lot of reports about talent being scarce in the data scientist area. Martin, do you find access to talent of data scientists to be a limiter in the peak business at the moment?
So I'm pleased to say no, and it's quite unusual really, because we're a fairly early stage business. We're coming up to our 3rd anniversary, and we seem to have no problem at all attracting data scientists, and data science is obviously a key component to our business. And I think it's because we offer a variety of use cases, industry expertise, so they're working cross-industry, they're working in a fast-paced environment, they're learning a lot of new skills, a lot of business acumen skills we bring to our data science team so they can converse with board-level execs around what their data means in a board-level exec speak versus an algorithm speak. And because of that, we seem to attract really good talent from a mixture of backgrounds, coming out of big industry, people who may be about to join the likes of KPMG, or people coming out of academia. So we haven't struggled at all, but we do see our clients struggle. And I think for the reasons I mentioned earlier, if you're a top of your game data scientist, you want to go and work in a construction business, for example, just giving one of our clients as an example, that will be a much more difficult hire for them, but we're okay at the minute. Thank you.
Great. Okay. Janet, what are your perspectives on building the right team?
It's pretty similar. You've got to have a really good value proposition to attract the talent, and that's not necessarily the highest salaries. It's about giving a really interesting problem. A lot of the good talent, they're really excited by having variety and having something that's intellectually stimulating. And if you can offer that, then you can attract the right people. And I've never had a problem hiring in both small and big companies for AI talent. But then it's also about getting the right mix of people in the team. It's no good having 5 or 6 people who all think in the same way and work in the same way. You've got to build a complementary team that can challenge each other and push things forward. So having that difference of opinion to help having constructive arguments in the team as to the right way of doing things, much like you'd build any development team. You don't want people that all say the same thing and do the same thing, because you'll never innovate.
Great. Okay, I wanted to move on to ethical considerations of AI, and David touched on this in his presentation. We've had people like Elon Musk saying that this could be a threat to humanity itself. There are some reports of machine learning models actually reinforcing biases in judicial outcomes for parole judgments. William, do we need to be worried about the consequences of all of this, and how do we deal with biases in AI?
So I think there's kind of 2 tracks here around this, the sort of ethics thing. There's the one of which is science fiction and one of which is kind of true now. So the Elon Musk story and some of the things you hear about sort of the end of humanity is about an AI that doesn't exist yet. It's a scenario where AI is intelligent enough to improve itself. And it also relies on assumptions like intelligence being some kind of linear thing that can exponentially improve. So you can imagine a system that's clever enough to improve itself. You get the sort of runaway AI scenarios. This is a science fiction scenario right now. Nobody can disprove that it can never happen, but the technology that we have right now is nowhere near that kind of capability. So I think that's really important to understand when you hear about the end of the human race type stories around AI. It is worth worrying about because the consequences are very severe, but it's not something that's close. The other side of the ethical side of AI is about automated systems. Biases are a very good example. Automated weapons, I think, would be another great example. The advances in vision, for example, can create automated weapons. So is it acceptable to have, I don't know, a sniper that will identify the enemy and kill them without any human being in the loop, or an automated bomber that will select targets and destroy them? Biases, there's a system in the US that gives advice about whether somebody should be let out on parole. It doesn't take race into account. It isn't one of the factors, but it takes into account all sorts of things that correlate very strongly with race, and it's been shown to be immensely biased. So, there are people who are in jail in the US as a result of an AI system that might not otherwise have been. AI systems for loans and fraud. Fraud was mentioned earlier. I think the current fraud systems that decline credit cards do use AI, and they do seem to arbitrarily decide that they're going to stop a transaction. People that have declined loans, they don't get an explanation. They're just told the computer system has told them that they can't get their loan. So explainability is important, and we have rules about we do have rules about decision making, about what is reasonable to include in a decision. But if you have a black box that's statistically determining a result using data and it's completely opaque, that does raise ethical concerns.
Great.
So,
Mark, in the medical world, I mean, how do you handle the risk of a misdiagnosis?
So that's obviously a very big concern for us, right? The good news is that medicine has been thinking about these problems for years, right? Human doctors also make mistakes. In fact, I mean, the scary part of doing what we do is when we actually compare doctors to each other and doctors to machines, we see how often doctors disagree on a diagnosis or how often they make mistakes. So we want to make sure that you have the right standards. Your machine doesn't perform worse than a doctor, but then you also want to be able to learn, right? If you make a mistake, how then do you examine your model and try to understand why did this mistake happen, and then how do you correct it next time, right? So nobody expects perfection from doctors, unfortunately. So I think we are getting very close in some areas, our company and others, to matching human performance, and in some areas, machines are beating doctors, right? If you're looking at X-rays and say, is this cancer or not cancer, there have been already numerous competitions and studies that show machines doing better than doctors. And I think over time, the trend will continue.
Excellent. And Martin, how do you work with your customers on this type of stuff? How do you educate them there's not going to be the risk of bias being introduced into their business processes?
Yeah, well, there's a couple of things really, I guess. On any project we would work on, we would drip feed in our insights to start changing their processes gradually. We wouldn't just obviously advise a big bang. We've cracked the nirvana to your biggest challenge, believers, and let's see what happens. So we can experiment without actually using live data in some cases. But for us, it's more about the AI plus human. So I think what's been echoed here, particularly in the medical world, if research I've done, so humans are much better at detecting things like false positives or false negatives in large amounts of data, and we see the same. So if we're working with a particular client of ours and we suddenly see something change by a larger magnitude that makes sense to a human, it gets stopped and it gets flagged immediately and it gets picked up. A human from the data science team will take a look at it, iron out the anomaly, and then we will retrain the model and go again. So I guess to answer that question, it's do this at a slow pace. Don't let the machines make every decision, and always have smart people around it who can spot anything that may be an anomaly.
Yeah. Great. Okay, just before we go to the audience to get some questions, I just wanted to ask one quite high-level one. I mean, we hear about Google, Facebook, Amazon all having these wonderful AI technology, but we've got this huge problem, it seems, at the moment of fake news, which is apparently influencing election results. So given AI is where it's at, how are we having fake news becoming the top of Google and Facebook at the moment? And obviously not trying to answer on their behalf, but Janet, have you got any thoughts on this area? What's going wrong?
Well, part of it is just the self-reinforcement of people's own cognitive biases. They want to read things that support their own views. So you end up with polarizing viewpoints floating to the top. And where you have AI that says, oh, you're interested in this, I will show you more of the same, you end up with that perpetual reinforcement, and the people in the middle tend to either get flipped to one side or the other on very, very minor things, which is a huge problem. What we need to apply the AI to do is to strip away what's just sensationalism from what's the underlying fact. And we as humans are astonishingly bad at that. And until we can be better at it, it's going to be very hard to create an AI that's going to be good at it too. But we need to be a bit more aware of what's going on and how we're influenced.
Okay, William, any views on that?
Yeah, so I think there's two different things here. I think what you're talking about largely is about the polarization of the newsfeed, the echo chamber. The fake news, as in stories that are untrue, I mean, the explanation for that is simply that AI can't do that yet. To work out that a story is not true requires reasoning and understanding of the world that automated systems simply don't have. So, and at the scale of the stories that we're seeing being published each day, for Google or Facebook to automatically determine that a story is false, I mean, there probably are signals from the domain it's on or something like that, but at the moment that requires probably human intervention. It's not something that can be automated with current technology.
Yeah, absolutely. And you add on to that the variation, so the misinterpretation of what could be a factual story suddenly becoming ever so slightly a variation of it that's not exactly true. It's very, very hard to pick up.
Great. Let's take a question or two from the audience. There's the microphone.
Hello. Hello. Hadrian's my name. Pleased to meet you. I was wondering if you might make a comment around the economic model of some of this AI, and where I'm specifically thinking is around the models of decision support, where ultimately a human might still be responsible for taking the rap if the decision is wrong, versus actually the AI actually making the decision. And I'm interested by the regulatory implications of that. My background is deeply in healthcare, so I'm very familiar with sort of Mark's story. But I was wondering if there's any experience from some of the other industries in terms of this, because clearly there's a profound impact if it's only decision support, because you still need an expensive human there taking the rap.
Martin?
Thanks, Nick.
So hospital pass there, so
Yeah,
sorry.
yeah. So I'm just trying to think in a scenario where we have, so I'll boil this down to a real life use case, and it's a non-sexy industry or use case, so apologies, but we're doing some work with a FTSE listed construction business, and what we're trying to do is drive optimization in their organization. They want to improve their return on capital invested. That's their number one metric. So we've identified, using AI and our clever people, that we think we can save them £27 million this year by getting them to sell off a whole bunch of assets in their business and return that to their bottom line. Now, you can imagine the nervousness in that boardroom when we said, we're smarter than you. And in fact, it was quite anecdotal. A comment that came straight back to us is, you don't know our industry. You can't mix sand and cement with a spreadsheet, right? So we sort of said, okay, what we'll do with this is we will actually, for the first 3 to 6 months, we will bet against you that we can predict certain variables in your business that are going to happen. We're not going to ask you to take those actions. You carry on as normal, and you see if you can be smarter than us over the first 3 to 6 months. And what we've proven is that we're way, way more accurate using the models that we've got and have developed for them. So they now have complete faith to invoke those insights into their business, and they are actually going to see those sort of returns that were predicted at the beginning. So it's a question of, don't jump in with both feet. You know, maybe model things out and sort of see how things would have panned out versus just doing it and hoping, and continue to let the human do the stuff that they're doing and see if you can outsmart them, would be our way of attacking that one.
Cool. Any more questions? Just one over there.
Just following up on that point, taking it kind of the next step further. If you've gone to all the effort for your customers and clients to get them to believe that your model is better than they are, do you think that trust is something that will continue to stay, or do you believe on the first time it goes wrong that will just be complete faith lost? How do you maintain that?
Yeah, so sorry, am I answering that, Nick? Sorry, yeah, okay.
We'll try and go to some other people.
Okay.
So I think this is, I mean, we touched on explainability a couple of times today. I think that is part of the trust issue. If the black box just spits out a decision or a result, it maybe can earn trust over time when you see it's working, but that's nothing like as good as being able as the AI system being able to give you an explanation as to how it came to that decision, why it works, and also, if it's wrong, that explanation often can flag that to the people that need to trust it as well. So, there's a lot of research. The modern sort of machine learning statistical techniques, deep learning are notoriously unexplainable. They're basically massively complicated calculations that are totally opaque to humans. And I think that is a serious problem in a lot of applications. In some applications it's fine, a lot of applications it isn't.
Mark, in the medical world, I guess in drugs they go through the phase 1, phase 2 trials. I mean, do we need to do phase 1, phase 2 trials of AI to get this confidence?
Well, we are doing very extensive trials of AI, right? And it's regulated by the same people who regulate human doctors, right? So that's why it's a very new technology, but the way to think about it is, in many ways, you can leverage a lot of the ideas that have been around regulating human doctors, human hospitals, the drugs that are designed by humans. So I don't think people talk about regulating AI as if it was something completely brand new. And yes, AI is brand new, but the problems that it's trying to solve are not. So we don't think that's a massive problem.
And Janet, have you got any perspective?
Yeah, I think one of the biggest problems is that as humans, we don't like devolving control particularly well, and we accept devolving that to other humans, but we're holding AI to a higher standard than we'd hold, especially in the medical profession. If you just said, oh, it's just as inaccurate as doctors, then people would be a bit nervous and they'd prefer a human doctor every time. But they'd want it to be more accurate. And yet if you told them that the result was by a human, not by an AI, they'd be much more comfortable accepting it. And that's just how we are. So I think until we start seeing a more level playing field, understand that what AI is giving us is just as good as a well-trained human, then we're going to get constantly the first problem, and people are going to want to switch to something else, whether it's a different AI solution or go back to humans. And that's something the industry needs to overcome.
Okay, and just to follow up, I mean, we are in actually not just in the UK, we are also in Rwanda, in Africa. We're working with many other countries. There are just not enough doctors there, right? So we can argue kind of for ages what's better, human doctor or AI doctor, are they like this or not? If you are in Rwanda and you don't have access to a doctor, period, and here you get access to an AI doctor, well, they're signing up in huge quantities to use our technology there, right? So we're not making a ton of money there, but we are bringing AI there because it's the right thing to do.
Excellent. Well, thank you. Oh, there's one more question.
What's the panel's view on sort of basic universal income and taxing robots? How do you think that's going to play out?
So I think we have like 16 seconds left. So really want to open that topic up. So I think I'm going to let somebody else answer that in 16 seconds.
I fundamentally disagree with taxation of innovation because it's just going to throttle us as a country. I think there are different solutions that need to be investigated.
Okay, let's wind it up there. Thank you to the panel. I think that was a really interesting discussion. And next we've got the healthcare panel.